Hey everyone, welcome to Homework 6.3. Today we looked at distribution and different types of data representations. So number one says the box plot represents the distribution of speeds in miles per hour of 100 cars as they pass through a busy intersection. All right, so this is the speed. Clearly somebody at 44 miles per hour was speeding through that light. And then somebody was really going slow at 8 miles per hour down at the bottom there. So it says, what is the smallest value in the data set? It is 8 miles per hour. It says interpret this value in the situation. So maybe there was a lot of traffic and there were a lot of cars going through and this person was going really slowly. Or maybe they were on a moped or something, right? So you can come up with your own scenario for that value. What is the largest value in the data set? This is 44 miles per hour, and they were probably speeding because they seem to be going at a much faster rate than the median here, which is that middle number. What is the median? So the median here is about 20, and again, that means that middle number, the 50% of the data, 50% is less than 20 miles per hour, and 50% is more. The first quartile, Q1, is 12. And that means that 25% of the data is less than 12, and a good 25% is between 12 and 20, right? And then our third quartile is here at 24. And again, that means that 25% of our drivers were going above 24 miles per hour. So that's a decent number of people. A quarter of the people were going above 24 miles per hour. But there's quite a big range here. That could be a lot of different values represented in between 24 and 44. All right, number 2 says the data set represents the number of eggs produced by a small group of chickens each day for 10 days. So 7, 7, 7, 7, 8, 8, 8, 8, and 9. Select all the values that could represent the typical number of eggs produced in a day. So the typical number of eggs produced in a day could be the mean or the median. So if we look at our numbers, crossing them out, right, one at a time, or I can do 2 at a time, 2, 2, 2, 2, 8 is our middle number. So 8 is our median, right? So that could be our typical number of eggs. We can also average these though. So if you add, and then again, I'm just gonna calculator, let's do it in a calculator. Here, if we add 7, 1, 2, 3, 4, 5, so 35 plus 32, 8 times 4 is 32, plus 9, which is our highest amount of eggs, divided by 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I did something. Hold on. So, all right, we'll divide by 10. Gives us 7.6. So our average is 7.6. Now, earlier I said the median was 8. I made a mistake because I did not count correctly. So we have 1, 2, 3, 4, and then 1, 2, 3, 4, which means we have 2 middle numbers. When we calculate the median of 2 middle numbers, we add, and so that would be 7.5. So those are the values that could represent the typical number of eggs if we are talking about the mean, the average, or the median. And that's because those are our measures of center. The dot plot displays the length of pencils in inches used by the students in the class. What is the mean? So again, we need to add all of those values up and then divide by the number of values. So we have 5 plus 5.5 twice, which is 11, plus 1, 2, 3, 4, 6 times 4 is 24, plus 6.5 times 2 is 13, plus 7. And then we're going to divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that will be 6. So 6 is our mean. 6 inches is the mean. Now, when you have symmetrical data like this that's perfectly symmetrical, you can generally also assume that that middle number will be the mean. When things are perfectly symmetrical, generally speaking, the median and the mean are going to be the same. Number 4, the histogram represents ages of 40 people at a store that sells children's clothes. Which interval contains the median? So which of these would have the middle number? Well, we have 10 values here. We have 4 values here, and then another 3, so that's 7. And then we have another 8 values here. We have another 6 values here. We have 5 here, and we have 3 here. So total we have, let's see, 18 plus 9 is 27, plus 8 is 35, plus 4, oh, I'm sorry, it says there's 40 people, right? So there's 40 people here at the store. And so if there are 40 people, then the middle number of those would be 20 and 21, right? So we're looking for those two numbers there. So 18, so that would be in this range right here is where we would be at 20 to 21 people, all right? Because we would have 7, 12, yeah. Make sure I did that right. 7, 12, 15, yes, and then so 15 plus 6 would give us 21. Yeah, so we would be right in this range here. And so that means that the interval that contains the median, or the middle number, would be between 10 to 15 years. It does seem like maybe this graph is missing some data here, though, because it says 40 people, but I only count 39. So if you can figure out why that is the case, let me know. Anyway, the interval should still be between 10 to 15 years. So number 5, the data set represents the responses in degrees Fahrenheit collected to answer the question, how hot is the sidewalk during the school day? So they're measuring the sidewalk temperature over the course of the day, and they have these temperatures. They're in order from least to greatest. It says create a dot plot to represent the distribution of the data. All right, so a key point here when we are creating a dot plot is that when you create the dot plot, it needs to be evenly distributed. And so we're going from 92 to 119. And so you might be tempted to skip numbers in between, but you really should list out each of the numbers. So 92 to 119 is going to be 827 numbers. It's quite a few. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 27. Okay. So 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 111, 112, 113, 114, 115, 116, 117, 118, and 119. Okay. All right. So 92, we have 1 value. 95, we have 3 values. 1, 2, 3. 98, we have 1 value. 100, we have 3. 1, 2, 3. 103, we have 1. 105, we have 1. 111, we have 1. 112, we have 1. 115, we have 2. 116, we have 1. 117, we have 2. 118, we have 1. And 119, we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. That's what our dot plot is going to look like. Oh, all right. It says create a histogram to represent the distribution of data. So here I'm going from 92 to 119. So I would probably consider this in terms of 5s. Right? So I'm going to think about this data from 90 to 95, 95 to 100, 100 to 105, 105 to 110, 115, 120, and then, yeah, stop there. Okay, so between 90 and 95, I have 1, 2, and it's, remember, it's up until, so it's including and up until, so 92 to 95, or 90 to 95 is actually only 1. And then make sure you label 1. And our highest amount was 5. So 1, 2, 3, 4, 5 when we did those increments. But it looks like between, it's going to be higher than that. So I'm going to need this to be a little bit taller. But actually, I'm just going to make it by 2s. 2, 4, 6, 8, 10. And this is at 1. So it's going to be between there, like that. Okay, so then 95 to 100 is 1, 2, 3, 4. So it's going to go up to 4. And then 100 to 105 is 1, 2, 3, 4. Then 105 to 110 is 1, 2. And then 110 to 115 is 1, 2. And then 115 to 120 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I needed to go even higher, 12. That's fine. Okay, so then it says, which display gives you a better overall understanding of the data? Explain your reasoning. So I think in looking at this, right, that the second histogram actually gives us a better display of data, just because when we look at the dot plot, there's not a value for each and every one of these. In some cases, there's only one value for a given temperature. So the histogram, although the dot plot gives us more specific data, the histogram gives a better overall picture and helps us to see that this data is skewed to the left a little bit because less of our data is on that side. So, oops, let's see. Better overall picture. Again, there's this data spread out from 92 all the way to 114, and so that dot plot isn't the best representation of the data to use in this case. It says, what is the area of the floor in this classroom? A statistical question. Explain your reasoning. You need to tell me. I'm not going to tell you. Yes or no, and why. Is that a statistical question? Are there multiple possibilities to answer that? Number 7 says, which of the dot plots show a symmetric distribution? So which of those dot plots in the side of the center would be even? And that's going to be B. All right. A is skewed left a little bit. C is somewhat bimodal, right? We have kind of like these two towers here. And then D, looks almost like it could be symmetrical because it's going up from the middle, but it's not perfectly symmetrical on either side. 8 says, which of the dot plots showed a skewed distribution? And so that would be D. This one is symmetrical here. A is symmetrical. B is also symmetrical. And both A and B are also bimodal. And then C is also symmetrical, but it's bell-shaped. So D is skewed right. It says, create a dot plot showing a uniform distribution. So you can make your own dot plot. 1, 2, 3, 4, 5. They each have 2 dots. They're uniform. Okay. Number 10, the data represented shows the number of ounces that students drank before donating blood. It's important to drink water before you donate blood. Create a dot plot for the data. Create a box plot for the data. So the dot plot, I'm going to let you do on your own because that you can work out for yourself. Now, let's look at the box plot for the data. I'm going to help you with that because to do that, we need a median. There's 26 students, so I'm going to count to 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right, so my two middle numbers are 64, and 64 averaged is going to be 64. So my median is 64. So on my dot plot, 64 is where the middle of my box should be, right? Now at the end, I have 8, and then way up above, I have 88. Now notice 64 is a lot further from 8 than it is from 88. It's only 24 away from 88, but it's 56 away from 8. And so when we sketch this out, then this should be a lot further away from this other one, right? We want to have pretty even increments, okay? So at the end is our 88, and at the other end is 8. And then we need to then find the median of the median. Okay, so now I'm going to look for the middle number, right? My middle was here. So now I'm going to look for the middle number over here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That means 1, 2, 3, 4, 5, 6, 7 should be my middle number. 1, 2, 3, 4, 5, 6, 7. Yep, so 80 is my next one. And that would be closer to 88 than to 64. So say 80 is about there. And then, so that's the end of my box there. And then on the other side, looking at 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 is 32. Okay, and 32 actually is going to be pretty much in between these two, more or less. And so we can mark. Now, you would probably want to create a scale that's a little bit more even than what I did. I didn't do the best job of making that a nice even scale. But you want to show that more of our data is on the higher end, right? More people drank 64 ounces or more. And so then there's this data here spread out from 8 to 32 quite widely. Says what information about the data is provided by the box plot that is not provided by the dot plot. So our quartiles, right? And we can find our median in the dot plot, but not immediately. So the median is immediately and instantly available to us in the box plot and not in the dot plot. We can calculate it from the dot plot, but it's not going to be quite immediately there. Letter D says what information about the data is provided by the dot plot, and that would be individual values, right? Because it's going to show us each temperature value. E, it was recommended that students drink 48 or more ounces of water. How could you use a histogram to easily display the number of students who drank the recommended amount? So if you were to draw a histogram, then you would probably put a certain number between between 48 and another value, right? So you might have, for example, let's say we did it in 12s, right? So we did like 12 to 24. Let's start at 8, right? So maybe we do it in 4s. So 4 to 8 to 12 to 16 to 20 to 24 to 28 to 32 to 36 to 40. Actually, I think that might be too big, the increments are actually too small. So let's adjust that. Let's actually do it from 12. So we'll do 0 to 12 to 24 to 36 to 48 to 60 and to 72. And we did get all the way up to 88. So we'll do up to 84 rather, and then up to 96. Okay, so maybe in increments of 12, because then we'll be able to see how many students were on this side of our histogram. All right, number 11 says the box plot represents the distribution of points scored by a cross-country team at 12 meets. If possible, find the mean. So we cannot find the mean, not possible, because we don't have those individual values, right? If possible, find the median. The median is 34. We can find it, so we don't need to explain that. So for letter A, make sure you explain not possible because we don't have individual values. C, did the cross-country team ever score 30 points in the meet? So we can't tell. They could have. If there was a line exactly on 30, then we could know. But we can't tell because we only know that 25% scored between 22 and looks like 33 points. But we can't tell if they scored exactly 30 points. Okay? All right, that's it for your homework today. Your code word will be vault. Vault is your code word for today. If you have any questions, feel free to reach out to me. Happy homeworking, and I will see you on Monday.